Welcome back to the Save It for Parts channel. In this video, I'm looking at a new way to make helical antenna feeds. So I have in the past 3D printed these helical feeds, and these are for circularly polarized satellite signals. And the basic design here is something that I got online. I think I got these from Derek SGC. He's another satellite YouTuber, and he's got some free designs on Thingiverse that you can 3D print if you have a 3D printer. This one is for L-band and this one is for S-band. Basically, these are just a scaffolding or support with a bunch of holes in them, and you wind up a copper wire, put it through the holes so you have this helical antenna feed, solder the bottom onto an antenna jack, put some kind of a base plate or a ground plane on it, and you've got a satellite antenna. Now, you can use a right-handed circular twist or a left-handed circular twist, depending on what kind of satellite signal you're looking for. And then if you use this on a dish versus aiming it directly at the satellite, you'll want to use the other direction because a dish basically reflects the satellite signal. So all of that's great. You've heard me talk about that stuff in prior videos. You've probably also heard me complain that my 3D printers are not very good at these. In fact, you can see some issues here. This one is actually two 3D prints glued together in the middle because these were two failed prints. It kind of works. I haven't used this particular one for a while. It's kind of falling apart in other ways. This other one started to be a successful 3D print, but the top here just got 3D printer cancer. So it's got some major issues and it's out of alignment. It also kind of works, but I have switched to something else. So these are two failed prints that I have basically given up on. And these weren't even the worst failures. These were at least usable. I have an entire box here of failed prints. We've got one here. I started trying to fix this by putting intermediate supports halfway up the structure, and that sometimes works, but sometimes as I print, the supports separate and you get that. Or there was another one that failed. Or here's one that didn't get very far at all before getting kind of this elephant's foot blob on it. Yeah, here's another failed one. Or like this one, which is another broken one. This is actually yet another failed 3D print that I've kind of thrown on the junk pile here. So as you can see, I am not good at 3D printing these helical antenna scaffolds. I'd like to find a better way to do it, some way that eliminates the need for a 3D printer, but also gives me a little more precision than I could do by hand. I've made antennas like this with just a piece of pipe and the coil wrapped around the piece of PVC pipe. I've seen people do it with popsicle sticks, with straws, with other stuff, and those kind of work, but they're not very precise, they're not very accurate. I want something that still gives me the maximum amount of signal for preferably the least amount of wasted plastic. So let's try a different rapid prototyping tool. Instead of 3D printing, I'm going to try laser cutting these helical scaffolds. Now, this should be a little bit easier in some ways and possibly a little bit harder in other ways. I don't know the exact measurements of this, and I am terrible at CAD, but I can work my way around MS Paint or Photoshop, and fortunately the laser cutter, all it really needs to work with is an image file, and then I can throw down different thicknesses of wood, plastic, other materials, and I can just have it cut out a vector file or even a raster file if I really want to. So all I really need to do is make some kind of helical scaffolding in several flat pieces and then have some join plates that will join those pieces together to make a little tower similar to the ones we have from the 3D printer. Another problem with PLA prints like this is that they are kind of temperature sensitive even when finished. So the antennas that I already have printed successfully out of PLA that I have sitting up on the roof of the garage, sitting on other satellite dishes, those might not like it in the summer. They might actually start melting once the sun comes out and it gets up to 100 degrees. So again, it would be nice to have something other than plastic. I know there are ABS and other plastics I could print in. I've actually not tried that on my 3D printer, and I've had so little luck with PLA that I'm a little leery of trying anything more expensive because I don't want to just keep throwing away failed prints. Since I am not good at CAD, I am doing it the very old school method of just measuring an existing product, taking some notes on it, and then ripping off Derek's design or copying his design over to a simplified laser engravable, laser cuttable version. You basically just need to know where these holes are for the helical wire, what's the diameter of the base, and then same measurements for the S-band antenna. As you can see, the L-band a little bit bigger than S-band, so I want to get measurements for both, and we'll see if we can duplicate each of these in a laser cut method. All right, we've got version 1 mapped out in Photoshop, actually GIMP because I don't want to pay for Photoshop, so I'm using the free open source alternative. I think this is correct, but we'll have to actually laser it out and see how everything fits, and then maybe we'll have to adjust some of the sizes slightly. For the actual laser cutting, I'm going to be using the Xtool P2 Pro CO2 laser. I still love that sound when I open the lid. And I'm going to be using 3mm basswood for this. Maybe not this piece. I'll have to see if my cut will actually fit on here. I've already used this to make a gear, so if it doesn't fit, I have some more chunks of the wood. Now this might be one of the colder temperatures when I've used the Xtool. It does live in the garage. It does have a water cooling system, but it had antifreeze that came with it. So there is antifreeze in the water cooling system, in the pump, in the laser tube, and hopefully everything keeps working. And it looks like the laser is actually upset about the temperature. So yeah, we have an L warning, and we also have a tank flow too low. So yeah, it looks like we can't actually do any lasering today because it is too cold, and I think maybe the antifreeze has gotten a little goopy. Second problem, I took this cover off the back just to make sure nothing has actually frozen or broken, and I had trouble with this cover before. You have to take off a whole bunch of bolts in the back, and you have to open up the inside, take off a whole bunch of bolts on the inside, and it had trouble before lifting out, and yeah, this time it actually snapped off all of the plastic bits that hold those inner bolts in place, so yeah, it has broken off every one of these along the side. Yeah, this thing is a little bit brittle because it's cold outside. It's not designed to be used outside. Even with the antifreeze, yeah, I should not be using this out in the garage, but I also don't really want to use it in the house because I don't have space for it in there, and even with the vent system that I have on here, it does produce a bit of smoke. On the plus side, nothing is cracked back here, nothing's leaking. The glass laser tube is just fine. The antifreeze is still liquid, so it's not like it actually got too cold and froze, it's just too cold for the little pump. This particular video is not sponsored by Xtool, although they did send me this laser for free a few videos back in return for a sponsored review. I've honestly been pretty happy with it, and I'm continuing to use it. So if you're interested in a laser like this, I'll throw some links to the Xtool P2 down in the description. All right, our cut is done. And yeah, I think that looks at least similar in size to the model that I based it on. And I could use wood glue to assemble this, but why wait that long? We have hot glue instead. So there is my L-band left-hand circularly polarized helical feed made out of laser cut wood. Yeah, as far as I can tell, it looks pretty close to the 3D printed one. It's a little flimsier. I might want to make this out of some thicker wood next time, or change the settings a little bit. Some of my holes here, my slots, weren't quite up to spec. They're actually all too loose, and that's why the hot glue is just holding it together. Now, for long-term use, I probably will want to use wood glue or super glue or something, just because I do want this to hold up in summer weather, and hot glue would just melt when it gets hot. We just need to coil a wire through it and test it out. I have a coil of wire about the right size, but I realized this is coiled in a right-hand circular polarized direction. Although I could use this for something like a disc cone antenna, which does use right-hand circular polarization, instead of a left-hand circular twist like we use for a reflector dish. I actually ran out of the stiff copper wire that I've been using for these helical antennas, so I stopped over to Axeman Surplus in St. Paul, and they have a big selection of random wires, scrap parts, all kinds of random electronics junk, electrical junk. So they're pretty much the perfect spot for any supplies I need for a project like this. Picked up a $3 coil of random stiff metal wire, and this helix is about the same diameter as 1.5" PVC pipe, so I'm just going to use a scrap piece of PVC pipe to pre-wind my wire. Just want to make sure to wind this in a left-hand direction, so we're basically descending as we go left here, or counterclockwise. People have asked me if it matters if you take the insulation off. Well, I don't think the insulation really causes any issue with an antenna like this, so let's just leave the insulation on and see what happens. One downside of keeping the insulation on this wire is that the wire is pretty close to the size of the holes I cut, so It is binding a little bit. If I had stripped off the insulation, it would probably slide through these holes easier. Otherwise, I'm just basically slowly winding this in here, taking my time with it so I don't break anything. Now down at the bottom here, this last hole, I put that a little close to the bottom, so I might have to drill that out a little bit just to get the insulated wire to slide through it. Alright, so just like the 3D printed helix, we want the last turn to bend straight and come to the middle here. And then this is theoretically a 5.5 turn helix. So from the point that the helix starts, we've got 1, 2, 3, 4, 5, and then the 0.5 would be right about here on the opposite side. So I'm just going to nip off the excess wire. Next we need some kind of ground plane, basically a piece of metal that goes behind the helix. And I could use an actual piece of metal stock that I got from my laser engraver. If you're really cheap, you could use a piece of wood and just cover it in foil tape. Or you can use whatever scrap metal is around, like an old street sign. I got this at an auction, I swear. Personally, I'm going to use this aluminum pan lid. It was in my pile of scrap metal to melt down in my little smelter, and it even has a hole in the middle already, so I can mount the antenna connector right through there. I still have to drill some holes for the mounting screws to attach the wood to this metal piece. I set down my wire cutters somewhere in here, and there's so much junk everywhere, they're just gone. So I've added a little SMA antenna connector to the bottom, and finally we need to solder that onto the center. And this is always the hardest part for me because I am terrible at soldering. Now, if I've done everything at least kind of right, we should have a little antenna. So I'm going to fire up the Nano VNA and see what the SWR looks like on this. Right at 1700 megahertz, it's basically just one SWR. So that's pretty much perfect. And it's pretty decent in a wide range of frequencies here. So all the way down to 1400 up to 2200 megahertz. I'm hooking this up to my folding dish since that's kind of the easiest to just swap out random antennas, and I'm just gonna duct tape it on here because, yeah, we're just testing it for now. If it works well, we'll put it on here more permanently, or we'll put it on some other dish. Now I also need an amplifier on there. I'm using the Nuelec Sawbird Goes, a filter amplifier. It's very well used, as you can see. I've been using this for a while, and it is starting to get worn out on the outside. People often ask if you can get away with receiving NOAA L-band GOES satellites without one of these, and not really. You definitely need this for L-band satellites. So I'll be sticking this on the back of the helix. I'm also using Nuelec's HackRF1 as the radio receiver, the software-defined radio. So the helical feed works pretty well for low Earth orbit NOAA satellites on L-band. Now, unfortunately, my image download is really choppy because I forgot to turn on airplane mode on my phone. So I had the phone right behind the dish as I was moving the dish around. And unfortunately, the Wi-Fi and 4G, 5G packets just interfered with the reception. So we get all these lines on the image. Totally my fault, not the fault of the helix here. This thing seems to be working pretty well. In fact, it's working so well that I actually have it aimed at GOES East, or GOES 16 right now, and it seems to be getting a clear signal from the GOES satellite, which is kind of surprising because this is a helical feed. The GOES signal is a linear feed, so this should not work very well for GOES. You lose about half of the signal strength going from linear to helical like this. You lose like 3 decibels, but we're getting a signal, and it looks like we're getting enough to actually decode something from it. Yeah, it's not the best signal I've ever had from the GOES satellite, but our deframer is solidly synced. We are getting packets, we're getting frames. Yeah, I only left that running for about 10 minutes aimed at GOES 16, and we've got some data, we've got some interesting images from it, so I'd say this little helix works pretty well. I tried this again with the Meteor M24 satellite, and that one worked much better because I remembered to turn on airplane mode on my phone this time, so did not get any interference. Had a really nice pass, really strong signal. I am still not a good antenna rotor, so manually aiming the dish around does result in a few little static areas, a few signal drops here and there, but that's working really well, and this little laser cut helix is working really well. So I think this is a big success. I think this laser cut helical scaffold works just as well, if not better, than a 3D printed model, and it's definitely easier to make than trying to fight the 3D printer. If you have a laser cutter, I will throw the files down below. I'll make those freely available if anybody is interested in cutting this out for yourself. If you don't like my design, it would be super simple to modify this, improve it, tweak it a little bit, and you could do S-band, you could do right hand, left hand circular polarization, either direction. Pretty easy to do. In fact, I think you could probably use the same file for right hand versus left hand if you just switch around some of the elements the way that they're aligned. For long-term survivability outside, I might coat this in something, I might paint it, and just the raw wood like that probably won't survive long-term, so we'll have to clear coat it, we'll have to seal it up in some way, and then we can use it outside kind of permanently, I think. And the laser cut scaffold is way faster to make than these stupid 3D printed ones. This Xtool laser makes this in like 3 minutes, where this takes hours to print. If it prints at all, sometimes it takes days because I'm just churning through failures. So yeah, for rapid prototyping, this laser thing is much more of a rapid prototype machine than a 3D printer. And this is literally my first try at this scaffold. I could make some more improvements to this. I could change the tabs. I could change the size of things. I just slapped this together in an image editor, cut it out, and put it together, and it works great. I hope this has been a useful video for everyone. Again, I will throw a bunch of links down in the description, everything from the files for this if you want to laser cut it yourself, links to the tools I used like the Xtool laser here, some of the software that I use, some of the other things that I've used in this video. I've gone over a lot of stuff, and this is definitely a cool new tool that I will be using probably a lot more in the future. If I can laser cut out antenna scaffolds like this, laser cut out other antenna designs, I'm going to try to do that more in the future because I've got some other ideas for stuff to do like this. Thank you also to my Patreon subscribers who help out with videos like this. They help me afford random supplies, equipment, even stuff like random pieces of wire. It always helps to have a little bit of extra money for that, so the Patreon supporters are a big help with all kinds of projects for this channel. Finally, thank you to everyone for watching, and we'll see you next time.